gallium nitride blow up? Optical isolated probe tells why. Gallium nitride devices have excellent switching capability. They can reduce power consumption and increase power supply efficiency. Widely used in the fields of low power supply. For power supply engineers, it's not just use the gallium nitride devices and simply increase power efficiency. You need to adjust all the parameters within a reasonable range. The premise of adjusting parameters is test, but the circuits made of gallium nitride are not so easy to test. The biggest challenge is MOSFET blow up. Gallium nitride could blow up in two scenarios: blow up right after power on, and blow up during test. Blowing up when powered on is because there are serious parameter problems in the circuit, which directly damage or short circuit the device. Today we will show you why gallium nitride blows during test. Before the test, we need to know a concept. What is gallium nitride blow up? Let's start with a half-bridge circuit. In the circuit, high side QH and low side QL are turned on in turn. As long as the two sides switching in turn, and the load current within its range, then it won't blow up. Normally we saw an explosion is not caused by load short circuit, only when the high side and low side conducted at the same time. Power supply VCC will be directly short circuited to the ground. Huge current will heat up the core device rapidly and lead to an explosion of the circuit with a stun sound. That is to say, simultaneous conduction of high side and low side would blow up the circuit. Now let's find out why both high and low side would conduct at the same time when testing with a differential probe. This is a gallium nitride half-bridge circuit. It's burned multiple times when we use differential probe to test, so we modified this circuit to protect it from destroy. We'll explain details later. Today we'll proceed test with this circuit. First, we need a high voltage differential probe from well-known brand Tektronix. It's a 200 MHz bandwidth probe, which can only be used on Tek's oscilloscope. So we have this 1 GHz oscilloscope from Tek as well. But only with these two equipment, we will not able to know the real reason why gallium nitride circuit would blow up. So, we need one more vital equipment, the OIP, optical fiber isolated probe. Why use this probe? Let's get to know what it is first. The OIP probe is the best test method for third-generation semiconductors. Third-gen semiconductor devices can switch on off in a few nanoseconds. Signal has faster rise and fall edges. Contains very high energy high-frequency harmonics. The OIP series probe can deliver nearly 100 dB CMRR, even at its highest bandwidth. Perfectly suppress the oscillations generated by high-frequency common mode noise. Meanwhile, it's very safe to test gallium nitride when there are doubts about the accuracy of results measured by other voltage probes. The OIP probe can be acted as the ultimate referee. Now let's get started. To prevent MOSFET blowing up, we set voltage to 3 grades, to 0V80V and 500V. In actual test, when the board gets 500V voltage, testing with differential probe will definitely blow up. Here we modified the board, lowered voltage to 300V, so the test can proceed safely. We connect the differential probe, CH1, and OIP probe, CH2, to the high side of VGS. Connect OIP probe, CH3, to the low side of VGS. This is when the high side switched on. We can clearly see the oscillation on the differential probe measured signal. This is when the low side switched on. OIP isolated probe shows slight oscillation. Let's try disconnect the differential probe. There is no oscillation on OIP probe. It shows that the oscillation is caused by the connection of the differential probe. Let's use the OIP probe to check the amplitude of the oscillation on the moment of differential probe switched off on low side. Check this voltage. It won't switch on the high side again, so won't blow up. Same position. Let's go up the voltage to 300V. We can see here, after high side switched off, caused by the differential probe, an oscillating signal generated on VGS, right on the moment when high side is switched on. Once the oscillating signal reaches the threshold, the high side will be connected again, while the low side is also connected. Both sides are connected, then the circuit will be shorted. If we increase voltage to 500V, the oscillation will exceed the switch-on threshold and blow up the device. But why the differential probe would cause oscillation? Let's remove the probe and short it. Check out the waveform. Although disconnected and shorted, the probe still shows signal. That means the two tips are actually an antenna. Received radiated signal from the switch, also known as common mode interference. This board has no load, but if there is a load current, the interference will increase significantly. When we connect the differential probe to VGS, the common mode interference will overlay on the VGS. When it exceeds the threshold, there will be a misconduction and short the circuit. Someone could say, differential probe can't test high side, but it does able to test low side. Let's try test the VGS on low side. Voltage set on 300 V. Same oscillation appeared. Affects the VGS signal. Optical isolated probe can prove that, whether explode or not, depending on after low side switched off, the oscillation amplitude when high side is connected. If the oscillation exceeds low side conduction threshold, will also short the circuit. After test and analysis, we can conclude that high voltage differential probes are unreliable for gallium nitride half-bridge test. It could blow up the device and get distorted waveform signals. It doesn't have any reference value, let alone analysis or calculation. But why optical fiber isolated probe can do? Deconnect the OIP probe. We can see a clear straight line, has no interference at all, hence no extra signal could damage the device. The OIP probe can resist interference because of its extremely high common mode rejection ability. Check out the CMRR of the OIP probe. It's outstanding. It unveils true signal you've never seen. For more information, please visit MikeSig website or send us inquiry directly. Thanks for watching.